Hello everyone, my name is Jared Cortez Navides, and this presentation is going to be about the frequency response measurements. My teacher is Dr. Laura Benitez, and it's for the junior lab class. And this is being recorded on April 16, 2021. Up next, we're going to talk about the presentation outline, in which we're going to have an introduction. Then we're going to talk about the procedures I did to get the results. And once we get to the conclusion, we're going to talk about the references and then move on to the question section. All right. Here we're going to be talking about an RC circuit, which is basically a circuit that's made out of a resistor and a capacitor. It could be several resistors and several capacitors, but in this case, we're just gonna have it like this. Next, we are gonna simulate an op-amp circuit, which is basically an amplifier circuit that could be either inverting or not inverting and has a voltage gain. We're gonna talk about the different measurement techniques, which could be maybe a simulated one, or maybe one that's done at the lab, or one that's plotted, or maybe just a sketch. And we're gonna determine the pole on each of them, which is the point in where the frequency decays 3 dB below its starting point. In here we have the circuit simulation that I did on LTSpice, and as we can see, we have two resistors in series with a capacitor, which this creates a circuit that's measured from 1 hertz to 100,000 hertz, and it's being powered with an AC signal of 1 volt. And in here we can see that we only have one capacitor, and we can just tell from that what the response will be, but we're gonna go ahead and see what the results is based on the simulations we did. And here we have the transfer function that I got from this circuit right here, and this function describes the behavior of the frequency response of the circuit. And I did this using techniques that I learned in my signals and systems class that will help me later on in my student career and in my working career. Up next, we are going to see how this transfer function actually becomes a graph here. These are called body plots and are measured in the vertical scale in dB and in the horizontal scale in hertz with a logarithmic scale, meaning that it goes from 1 to 10 to 1k, as you can see here. And on the one on the bottom is just a sketch that I got from this function right here, and it can tell me just so much about the system. However, the information that I get is precious because it tells me what the response is, and I can just like work with that if I were to just want a simple response. The one on top is the plotted one on MATLAB, and as you can see, it is more precise, and it can tell me more about the system response, because as we can see, it is very defined over the intervals. However, when it comes to defining the pole, it is not as intuitive because like it doesn't say as much as we want. Finally, the one in the middle is the simulated one from LTSpice, and that one tells me everything about the system, about the response, the pole, the time, everything. And that one is the best way to get it. However, this method may not be available all the time, and that's why it is important to know these other two methods. Here we're going to talk about the face of the system, and as you can see in all instances, it is pretty much the same, and we see the same pattern, that the one that's a sketch can tell me just so much about the system. The one on top, which is the plotted one in MATLAB, tells me just just about enough about the system, but the simulated one tells me everything about the system. It tells me where it starts, what the bottom is, everything. Up next, we are going to discuss about the differences between all these methods, and I'll label it as this on the right. First, we have the straight line body plots, which tell us a little about the frequency response. Then we have the one from MATLAB, which is a plotted one, and that one tells us more about the system. But the one that tells us the most is the simulated one from LTSpice. Up next, we're going to talk about our other circuit, which is an op-amp circuit that's made of a TL081 circuit and powered by 15 volts on the positive and the negative terminals. The voltage in a sinusoidal wave, it's 10 AC volts, and it's made out of two resistors, which are 33K and 2.2K. On the right, we can see equation number 2, and that one is the op-amp gain equation, which will tell us what the gain will be for this circuit. However, we can only have so much gain because of the component limitations and from the voltage input limitations. Alright, so up next, here I only plotted this on LTSpice, since now I know that's the best way to go about this frequency measurements. And as we can see, it starts from 44 dB and it goes all the way down to negative 180 dB. For the phase, it starts at 0 degrees and it goes down to negative 360 degrees. Up next, here in the results and discussion, we can see that these circuits are low-pass filters, and the gain of the op-amp circuit was of 16, which I got from the formula, from equation number 2. And I can determine that it's a non-inverting circuit because here I can see that the voltage goes into the positive terminal of the op-amp and not into the negative, and that alone tells me that's a non-inverting one. However, I still did the simulation just to make sure. And here we can see different poles locations, the amplitude, where it starts and where it ends, the final frequency, the phase starts, and the lowest point of the phase. And this is all the information and the measurements that I got from the circuit. However, we didn't get to do it on a breadboard on the laboratory because of, the pandemic situation and all that's going on. However, I would have liked to do it because it would have been fun to. And in conclusion, we can see that the frequency response refers to the way that a circuit changes as the frequency varies. So it's not gonna be the same at all frequencies. And that it's a good thing because we can apply all those changes into situations and parameters that we want. And all the body plots that I did tell me the same information. However, the simulated one tell me the most information out of all of them. And here are all the references that I looked up for this experiment. And if you guys have any questions whatsoever, just send me an email that's right there and I'll be happy to answer you.